Are you gonna be at Jill's house?
No.
All right, who wants a present?
Me. Who's what? Oh, I said me.
Because I love you. Exam review packet time.
Okay, I love the paper pockets. They have
You
things
want,
on
you want the key to unlock success?
Oh.
Here you go. What's up, guys? Enjoy.
Thank you.
Yeah. You know, I thought you had one last time.
No way.
44 pages.
Wait, 44.
I'm pretty sure last semester I did
Oh my
I locked my pencil.
Okay, guys, truly, hey, truly, if you want to do well, everybody hearing me? If you want to do well, you'll know the stuff in this packet. Every time you skip one, you're running the risk of missing a problem on it. So you're like, oh, I don't know how to do that. He probably won't ask it. Probably will.
It's like,
This
it's like one.
So obviously it's not 44 pages long. It's about, I'll tell you.
It was like the game last time. I feel like Steve. And you're at like that's what that hour.
Is it the echo exam?
Oh my god.
I don't know, take it.
He's still going.
It's 11.
What?
But there's a ton of it that's multiple choice. So like, for instance, here's a problem right here that normally would require this much space. It requires this much space because I have all the multiple choice answers. So 11 is really misleading. There are 63 questions, which is very, hey, this is very normal for my exam. It's always 60-ish.
Guys,
And-
this is bad.
And it's 2 hours, what hour and 50 minutes, and I let you take, what does it go, 6, 7, 4, 5? So you'll finish up around noon, and if you need an extra 15, 20 minutes, I'll give it to you. We go from 9:10, from 10:10 on the second exam to noon. And I believe we're the second exam, right? Is it
Yeah.
6, 7, 4, 5, 2, 3, 1? Yeah, so we'll be the fifth period exam. We'll be that second exam on the Tuesday. So anyway, you'll have time, is basically what I'm saying. 6, 7, yeah. So you'll be the second exam on that Tuesday. If you need a little extra, I'm happy to give it to you, so don't worry about that. But yeah, guys, listen, there are no surprises. Literally, all I do when I make out this test is take the review sheet, which you have in your possession, pull it up onto my screen, and start throwing problems out. And then by the time I get it to where I think it's a doable number of problems in a certain time period, I just change numbers. And on this particular one, to help the grading, I made it multiple choice. But that being said, here's what I do with the multiple choice. Now, not all of it's multiple choice, but a lot of it is. So you will have it, and I'll tell you this again beforehand, but you will have a sheet on there where you write all of your answers for your multiple choice. It's like an answer sheet, like you can circle them as you go, but you'll write all your answers on there. And then on the rest of the front and back, you'll have a few more where you do the work. And then there'll be a small calculator section. It's front and back where you'll have your calculator. Maybe it'll be like problems where you find the area or they use law of sines or maybe stats or something like that. So when you get done with the major part, you'll do the calculator part or vice versa. Sometimes I give you the calculator part first. But bottom line is this, I grade it right or wrong multiple choice. Then I go look at what you needed to keep your A or your B. So if you needed like a 72 to keep your A, right? Let's just say you had a pretty good average, right? And you make a 69 and you lose it. Then I go back and regrade all your work. Now, I don't just regrade the work of the ones you missed. I just literally regraded a second time based on work as if it wasn't multiple choice. And then usually Well, not usually. Sometimes that might bring you up a couple points. It probably wouldn't bring you up a couple points if you were just purely guessing. Because when I go back, you might have hit some right on a guess, but when I go back and regrade it with no work, you miss it. So I will give you the best of those two options. But if you do get what you need, then I just throw it in there and everybody's happy. All right. And I did that, and every now and then it's usually the averages are within 2 or 3 points of each other, grading multiple choice or showing your work. There was one person once who did 10 points worse on the multiple choice. And I went back and they had 5 questions, worked correctly, the right answer there, circled the wrong letter 5 times. Or maybe it was 6 times, whatever it was. They were about like whatever, 1.5, 2 points a piece ish, cost them 10 points. And I was like, well, you're lucky I went back and graded your work, because when I graded the work and not the multiple choice, they got all of those right. I don't know how somebody does that, looking at the right answer and just, well, I think I'll go with C. It doesn't make any sense to me. But anyway, it's a pretty fair test. It's not overly difficult if you do the review sheet. If you do not, you're going to have trouble, because we've covered a lot of stuff this year. And also, it's a year-long test. It's not a semester. Now, before you whine about that, because I know there's a tendency of, that's too much. Keep in mind, for me to be able to test you on every topic, I have to water it down a little bit more. So honestly, I think it's probably an easier exam. I tend to now have a little bit better grades because I have to cover all the topics as opposed to just half of them. So I can't go into each topic as deeply. So I tend to be a little bit more surfacey on all the topics. But you see that on your sheet. If you can do all the problems on this review sheet, this will not be a difficult test for you. You should be able to keep your average, if not even bring it up a little bit if you're close. Like if you're sitting on a 79 right now and you're like, man, I need an 84 to get my B. Well, do it twice. Do it once, check and correct it. I'll put the key up soon. Check and correct it, and then go back through and do it again with the ones you missed. If you really want to improve, you can. So especially now, if you have a 72 average for the semester, you're not getting a B in here. It is mathematically impossible to do that. But it was totally possible to bring up like a 78 to an 80, or maybe even a 77. You have to really do well. Or if you have like an 88 or 89, it's tough. 89, you can totally make a 92, 93 in this, get your A. And then remember, I always drop your lowest test grade if your score is a A or a B and better than your lowest. So if you can make an A or a B on this, and say you have one crappy grade. I got a person who has made A's on every test as high as 103. One test, 69. And it is driving his grade down to a B right now. But his B makes a 85, 86 on this exam, and I toss that 69. Boom, everything jumps up. He's got an A for the semester. Sure. Yeah, absolutely. All right. So anyway, did anybody just walk in and not have this?
What page did you? All you do clouds. What was on page 10?
Was it?
All right, guys, does anybody have any questions? I'll probably repeat this for the other people that aren't in here right now, but yes.
It's not on the.
Not in the packet?
Yes, you can put it.
I guess you can't, wait, no, it's on here. It is?
No, it ends with stats.
No, isn't it not?
Counting with probability, page 37.
Oh.
Dumb.
Probabilities earlier in the book.
Yeah, it may not be in the right order because sometimes I change up the order.
I would say spelling.
That's it. Isn't it? Yeah. But again, guys, by the time we're done with this, I mean, the counting and probability problems you see on here, I don't think they're as tough as what we've been. And guys, again, if I didn't say it in this class, maybe I said it in the other ones, it is very common for people's heads to spin a little bit after that first week of stuff. But really, as we go through today, you're going to see we're not really doing anything new. It's just different kinds of problems, looking at different kinds of things. And we're going to do it today, Monday, Tuesday, Wednesday before our test on Thursday. So you very likely will start getting into a little bit of a groove on all of this by the time we're done. That's my hope. Most people do well on the probability if they keep up. The ones that don't are the ones that are like, oh, it's all good. And the night before they go look at it and they're like, what on earth? Those are the ones that get beaten up. And even some of those don't, because Some people are just really good at math and they're able to bail themselves out. But you probably know that who you are at this point and how your strategies are working. So if you don't, then what's the definition of insanity? Yeah, doing the same thing over and over again, expecting different results. Yeah, that's crazy. So if it's what you're doing is working for you and you're getting A's, great. If working for you is getting C's, then whatever. But I would rather not have C's than B's if I can get A's. I was capable. Yeah. I am not taking that for points, which for some of you is the kiss of death, because or for some people in the past, because they hear I'm not taking up points. Sweet, I don't have to do it. I will absolutely crush your soul and spirit. I read that this test will do that. It's a lot of material we covered this year. To not remind yourself about all of that it's a recipe for disaster. And here's another one. Well, I'll go through the review sheet and do what I can do. Why bother? You already know what you know how to do, right? If all you do is go through the review sheet and do the problems you know how to do, you literally aren't getting better. It's the ones that you don't know how to do that you need to do. And I would certainly do the ones you know how to do just to see if you actually do. But if you don't do the ones you don't know how to do, you're doomed to miss those. And every year I do, I don't take these up. I doubt I will. I might change my mind and tell you, hey, I'm taking all these review sheets up. But when I did give points for these, I would have some, I don't know how many problems are on there, maybe 200. I don't know, whatever there are. I would have people that would do 100 out of the 200. And I'm like, you're doomed to miss out the test. And sure enough, 55, 47. And very few people can make a 55 and keep the grade they want. If it's you and you pull that off, I don't have a problem with it. Because you have earned the right to suck. Okay? If you have 100 average, truly, you have earned the right to need a 58 on this exam. And you probably won't make that. You'll probably, I had a grade like that once. I remember in high school on a math test, and I needed, I think, a 57 to keep my A. And I didn't even look at the material. And I think I showed up and made an 81 or whatever like that. But I had 101 something average in the class. It didn't even bother me. I had a college Euclidean geometry class that I needed a 20 something to keep an A because he had a terrible way of calculating grades. It was wonderful for me. I took advantage of the system. This guy actually still teaches at Auburn, and my son had him. And my son goes, "Oh, I'm so-and-so. I don't know if you remember him, Reddit guy." He goes, "Yes, I remember that guy. He blew up my system in Euclidean geometry." I was like, well, took advantage of what he offered. But anyway, just do the review sheet, check it, correct it. The key will be on Schoology. We'll have at least 3 days in class to talk about things you have issues with. I will give you 3, even if it means we don't have time for a quiz on piecewise functions or whatever. You will get 3 review days, that Wednesday, Thursday, Friday. But don't not do it. It's just a rest. And every year it saddens me. Every year I have 1 or 2 guys. All I got to do is get a 72 to keep their B or something like that, or a 72 to keep their A, and they make a 65. And I go back and regrade it, and it's a 68. And I literally have had somebody once walk up to me, and they're like, they made like a 77, and they needed I think they went into the exam with a 91. Or maybe they made a 67, whatever it was they just got hammered. And they came up to me and they're like, "You got to give it to me." I'm like, what? Like, you made a D and you want me to give you an A? Like, you literally know a D's worth of material and you're arguing for an A. It'd be one thing if you needed a 94 to get your A, right? And you got a 92. At least you made an A on the test. I don't know. You probably wouldn't even know. I probably would fudge your grade a little bit. So you'd never even know I gave it to you. You'd probably "Oh my gosh, I hit it on the jackpot." Yes. But if you miss it by on the low end, you're not going to get mercy. All the test questions are in there. I've just Where's Waldo'd it, I've just filled it in with enough other stuff. You're just going to have to know it all to be able to know. So anyway, back to this. So we're on probability. Did anybody have any questions about anything with probability part 1? Oh, one last thing. I really don't want to talk about this review sheet until we start reviewing. I'll put the key on there as soon as I think about it. You're welcome to check and correct, but I have so many other things on my plate to try to do with my other classes, thinking about review and stuff like that. I'd rather not. Just wait. We'll have plenty of time. Focus on what you know how to do. Use those review days to ask questions about what you don't. Yes. It doesn't matter because it's a one separate unit. I graded out of 100 points. What's going on here? I graded out of 100 points. No.
Oh, so it just gives you an average.
There we go. Yeah, because it's a whole separate unit. It wouldn't matter. It's just your average that goes into there. I don't know why I've literally lost control of this. Can I write on it? I can write on it. I just can't move. Isn't that weird? But it's moving. Just not. Oh well, I have to make do. This thing's acting up today. All right, so we're on probability part. So anybody have a question about part 1 probability? I said to go through there and do as many as you can.
44.
44? So 44 says evaluate this. Don't worry about something like this on the test, but I want to show you. I put it on here because it was a combination question, and I thought it was kind of clever. And maybe you don't notice this, but it was a great question. I remember seeing it going, how on earth are you going to do this in ciphering? And then I was like, ooh, that's clever. Okay, so you may not remember this, but did you know that Pascal's triangle was actually a pyramid of combinations? It is 0C0, 1C1, 1C0, and you could go either way. 2C2, 2C1, 2C0, 3C3, 3C2, 3C1, 3C0. So like this right here, that's 1, 3, 3, 1. 1, 3, 3, 1. Well, what does that expand to? Sigma notation tells you to what? Plug in the 0, add, plug in the 1, add, plug in the 2, plug in the 3, and keep doing that. Sadly, not to 12, but to 12C10. Now, do you remember the question I gave you guys that said, find the sum of the terms in the 3 row of Pascal's triangle? And the trick was 2 cubed. If it was in the 4 row, 2 to the 4th, 10th row, 2 to the 10th. Well, this is the 12 row. Only problem is it's just 2 terms shy of 2 to the 12 of the 12 row. The 12 row goes from 12C12 to 12C0. This comes up a little short. But couldn't you do this? Couldn't you just say, well, the whole 12 row would have been 2 to the 12th, but I just need to get rid of the 2 that weren't in my expansion. And what's 12C11 when you do the math? And 12C12 is 1. So I get 4096 minus 13. Now, again, I'm not going to put that on your test because if you didn't remember your little math team trick, you'd be sitting here all day calculating these combinations, not to mention adding them up. But if I just said, we're not simplifying anyway on this test, so if you just wrote it all out, I guess you would have been right. But that's what you had to do on this ciphering question. I doubt, honestly, anybody on our team got it when they threw it out there, because most of the time they just don't relate that to a row of Pascal's triangle. I thought it was a cool question. And it had a combination in it, and we're looking at that. So, or whatever that's worth. Come on. What else? 40. Let's just go one at a time. So it says June, Connor, and Daniel are playing a game in which each player secretly selects one of the other 2 players. All selections are revealed simultaneously. And if all 3 players are selected, then the 3 guys win the game. Otherwise, they must begin the process all over again. What is the probability that they win the game on the 3rd try? So if they win the game on the 3rd try, that meant what? They lost the first 2. So it says they win the game when what happens? It says each player secretly selects one of the other 2, but everybody's picked. So I can win when what? What are my options? Think about June. June could pick Connor, or June could pick David, right? I could have Connor could pick June, and Connor could pick David, and it's not David, Daniel. And then Daniel can pick June, and Daniel can pick Connor. So the only way they would win is what? If he picks him, right? Then what has to happen?
Connor chooses David.
Connor chooses David.
Or David.
Dang it, Daniel, and Daniel chooses June. That's one option.
Or that
What else could happen?
other three.
Or June can pick Daniel. Connor can't pick Daniel. That would be a match. Connor can pick June, and Daniel can pick Connor. So there are what? 2 ways to do it out of what? Out of 6. So there's 2 ways to do it right out of 6. There's a 4-6 chance that they're wrong. Are you with me? Because I could have that would be wrong, that would be wrong, that would be wrong, and that would be wrong. So there's 6. Oh, wait. 8 total ways of doing it, right? 2 ways to be right, 6 ways to be wrong. 2 times 2 times 2, 8 ways. Are y'all with me on this? I'm 99% sure I'm right so far. So this would be a loss. If they play the game again, then what happens? So they played the first game, and they what? Played the second game. What am I doing wrong here? And then they won on the third game. And the third game is what? 2 of the 8 ways.
Oh, he does.
And if I cancel this, that's not right.
I think I might get 6 out of 6.
Oh, yes. So I was thinking 4 out of 6. No, 6 out of 8. So there's 2 ways to be right, 6 ways to be wrong. So I'm wrong. I lose, I win. Yeah, that's better. So that gives me 72 out of 8 cubed. If I cancel an 8 out of that, I get 9 out of 8 squared. So kind of ugly. And again, not something I really feel like would be on your test. I mean, I like you to see these math team questions because they make you think a little bit outside the box. But you bottom line have to look at every possible option. But if you think about it, June has 2 choices, and Connor has 2 choices, and Daniel. So there's 8 total choices. But there's only that, or that would be correct. So that's a win. That would be the complement. That would be the loss. And you had to go loss, win. What else? Oh, yeah, y'all asked about that. A euchre deck. I don't know if this is actually real or made up. It doesn't really matter for us. It's telling you that there is a deck of cards, supposedly, that has these 6 cards and in each suit. So evidently, the 2 through the 8 are not a part of the deck. So they're calling that a euchre deck, right? Find the probability of being dealt a full house. Now, we'll talk about cards more and more. And on a real test, I won't use euchre decks. I'll use a standard deck of cards, 52. But this one right here, a full house, if you don't know, means 3 cards of 1 rank. I'm using their words. Rank is the same thing as a what? As a kind, okay? And then 2 cards of another when dealt 5 cards from this deck. So what's the probability of that? So here's the thing you have to do, and you got to think about it. Does it specify which kind you're going to have 3 of a kind for? So choose it. How many kinds are there available for you? There are 1, 2, 3, 4, 5, 6. So there's 6 kinds, and you're picking what? One of them. Now, I know you can write the number 6, and if you do, you would be correct. But later on, you're going to see how sometimes I can mess with your brain I haven't completely decided if I'm going to do it this year. And you got to be careful. Talk about this later. I probably will do it. I just might not test it, but we'll see. All right. Now, all this did was count the number of ways you could get 3 of a kind. Now, once for each of those ways, whether it's a 9, whether it's a 10, whether it's a jack, how many ways can you get 3 of a kind? You're picking 3 from what? From the 4. So that would be 4C3. So 4C3 says, hey, there's 4 kings. How many ways can I pick 3 of them? All right. So you could pick like not the king of hearts, not the king of clubs, not the king of spades, not the king of diamonds. That's 4 ways. That's what the 4C3 gives us. If I calculate that, I get 4. But nobody said I had to do kings or queens, right? I could do any one of those 6. That's what the 6 to choose from. So this counts which of the suits I'm going to have, basically, and this counts how many ways I can pick those 3 cards within that suit, right? So that's your 3 of a kind. But then you also have to do what? 2 of a kind. Now, when you go to 2 of a kind, how many kinds are left? Only 5 are left, of which you need to pick 1. So this would be a 5C1. So this part goes together. This is you're counting the 3 of a kinds. How many ways that can happen? 3 of a kind. And now you're going to pick one of the remaining ones. Like if this was a king, there's no kings to pick from anymore, right? Are you with me? So now once I count up the number of ways that could happen within each of those kinds, how many ways can I get 2 of a kind? So like within a king, how many ways can you get 2 kings? 4C2? I don't have to actually figure that out, right? 4C2, so times 4C2. And this counts 2 of a kind. And then that just counts them. And the question was probability. So how many cards were there to choose from? Remember, the denominator is just, you're picking 5 cards, right? So there's 24 to pick from, and you're picking 5 of them. Now, on this test, you actually had to do the math. Now, the nice thing about the math is 6C1 is 6, 4C1 is 4, 5C1 is 5, 4C2 you might have to think a little bit about, but it ends up being 6. And the only real challenge is 24C5, which is 24, 23, 22, 21, 20, all over all the other 19 factorial cancel over 5, 4, 3, 2, 1. And a 5, 4, 3, 2, 1 on the bottom is a 5, 4, 3, 2, 1 on the top. So this ended up being kind of a dirty ciphering question because that's going to be tough to simplify in the time that you have. So you're going to have to do the best you can and stuff like, I don't know, 5 times 4 is 20, get rid of that 3. Again, not pleasant whatsoever. 6 times 4 is 24. Maybe that 2 is an 11. But at some point, there's your 30. And then you're going to have to go and I guess 23 times 11 is what? 253. And 253 times 7 is 1771. So you might be able to get there, but I doubt anybody got that problem right in a 2-minute time interval. It's pretty tough. And for the record, I don't know that 253 times 7 is that. I'm just assuming. I mean, so even that took me a little bit of time. I can't imagine somebody getting that right. But the guy that used to run the Hoover tournament, he's over at Mount Brick now. He's an absolute genius. And I think I've told you this, but once he put a problem on it, it took me like 6 minutes with a calculator to do. I called him up and I'm like, what don't I know? Like, what trick are you using? He goes, he sent me the solution. I'm like, well, that's what I did. I said, dude, that takes 5 minutes to do that ciphering problem with a calculator. And literally he texted back, sue me. Like, I'm like, why do you even put that on there? I mean, on a written test, one thing, but a ciphering question? Anyway, I think he took pride in stealing your man or womanhood from you. I got this. You marched down there for ciphering. How many points you get? None. I think he kind of took joy in that. Anyway, what else? Again, probably not something, certainly not something you have to set up, but that is something that you would have to do on your probability. But we'll spend a whole day doing card problems like that, and they won't be euchre things that mess with. Yes. Jar contains orange and blue marbles only. The odds, okay, they threw out odds. I always like to convert odds to probability. I tend to think better in probability. So I'm going to write odds of a blue. I'm going to do this. if the odds of a blue are 5-3, what is the probability of a blue? 5/8. The odds of pulling a blue marble from the jar are that if one more blue marble is added to the jar, now the odds of pulling a blue marble from the jar are 7-4. Now, these might be simplified values, right? Right? So remember, 5 out of 16 might be different. So if I add one more blue marble, how can I think about that? So here's what I did. I looked at this as 5x and 8x because there might have been a common factor that got canceled, right? You with me? So if my initial probability is this, it says if one more blue marble is added, so I'm going to add an extra blue marble. Adding a blue also adds ones to the total, doesn't it? Are you with me? So if I added one, now what are the odds? Which means now the probability would be what? 7/11. So it was that. If I add a blue, which is also adding a total, now it's that. Well, I have a system of equations. Not a system. I have an equation with one variable. So I can say, all right, 55x plus 11, 56x plus 7, x equals 4. And if x is 4, how many blue marbles did you originally have? 20. Again, probably not something to be on the test, but I like you to see that kind of stuff. It kind of stretches you out. What else? Anybody else? All right, let's check out part 2. Okay, I think I've done a much better job this year of throwing terminology out before we even got here. And you probably already know about independent and dependent. So an independent situation just means as you're making your choices or as you're doing the problem, any subsequent event that you're trying to figure out is what? Independent. Is not related, is no bearing, has not affected at all by anything that happens prior to that. Flipping a coin, rolling a die, pulling a card out of a deck and then replacing it. Because the next time you pull one out, the probabilities, all the numbers, nothing has changed. So anything with replacement or anything like flipping a coin, rolling a die, that kind of stuff. Now, also to throw into independent are occasionally some dependent things. And this is sometimes where it gets a little tricky. Like, for instance, do y'all know anything about batting averages in baseball? Okay, so if you don't, it's okay. If they call you a 300 hitter, that means you have a batting average of .300. All right. What that means is, on average, you get a hit 3 out of every 10 times, which makes sense, right? Because if the probability is 0.3, that's how they do a batting average. That means you're going to hit on average 3 out of 10. Now, does that mean for certain that you are going to, on the next 10 hits, you're going to get 3? No, you might be in a terrible slump, right? Maybe you go 10 for 10 on your next 10 at bats. I mean, stuff like that happens all the time, but it means on average. Now think, in real life, if my average is 300, let's just say I have gotten 300 hits out of 1,000 at bats. What happens if I get a hit in my next at bat? Has my batting average changed? Yes. Now I have 301 hits out of 1,001 at bats. Now it's probably still pretty close to 300, right? Maybe 301 or something like that. But normally, every time I get up and actually have an at bat, my batting average is slowly changing and it's evolving, right? But I would never be able to you would never be able to calculate that if I said, hey, I'm a 300 hitter. I'm a 300 hitter, but I went 3 for 3 last night. So what am I hitting now? You wouldn't know how to calculate that because just knowing that I'm a 300 hitter, you don't know how many hits and how many at-bats I've had. You just know that simplified fraction. Are you with me? So what I have to do in a case like that is go, well, I just got to assume if you're a 300 hitter that it's a independent event because I don't have enough information to change it each time. Are you with me? Like what if I told you, hey, you magically can pull a king out of a deck 1 out of every 4 times. And you're like, well, that's pretty good because normally it's 1 out of every 13, right? You pull out 1 out of a deck, but actually it's not even 1 out of every 13 because the second I pull 1 out of a deck, right? What happens? There's 1 less card and 1 less queen, right? So if I said that you had that magic, you'd be like, I guess I just got to stick with it because I don't have enough information to really know. So there are going to be certain circumstances where real life situations that are actually dependent, we don't know the information to be able to change the probability. One of those is like percent chance of rain. Like they said today was a 90-something% chance of rain. I haven't seen a drop yet since I've woken up because it rained at night, right? It's been pretty nice out all day. Cooled off a little bit in the 70s. We're stuck in here, but it's in the 70s, right? But my point is that rain already happened. Okay, yes, it's evaporating and moving back into the sky and forming clouds or all that stuff too. But sometimes those probabilities, if it says 90%, even though something might have happened, I just got to assume that it's an independent situation because I don't have enough info to be able to recalibrate and adjust. So you're going to see that on a couple problems. One of them is chance of rain, right? If I say, hey, there's a 40% chance that it rains this week. Now, does the fact that it rained on Monday in real life maybe affect Tuesday? Maybe. And I don't know that. So I don't know that information. I'm not a meteorologist. I got to just stick with 40%, 40%, 40%, 40%. So in the absence of information, sometimes dependent situations might have to be thought of as independent. But moving on. Dependent. Dependent we've talked a ton about, right? Pulling marbles out of a bag. You pull one out and don't put it back. Things are changing on your next choice. Get dealt a card. Things are changing on your next deal. Those are dependent situations. And dependent situations, the whole idea of them, right? 4 queens, 3 queens, 2 queens, 1 queen. What does that sound like? 4, 3, 2, 1. Factorials, and factorials are the building blocks of combinations and permutations. So if it's dependent, you've got a fighting shot to use combinations and permutations. But if it's independent, right? Pull out a king, put it back. Pull out a king, pull it back. 4, 4, 4, 4. That's not changing. You cannot use combinations and permutations on that. You can't. All right. Now, I still might have to count the number of ways something could happen using some factorials, but I can't use combinations and permutations. Are you with me on that? Okay. And then what did we talk about in that order? If I say in that order, then I can't really use a combination at all, can I? But I could still use P. And if it's independent and I'm writing out the individual fractions for each choice, but then I count them at the front with factorials, right? How many ways it could be arranged? We're going to do this today. If I said in that order, then I don't have to count them out front with those factorials. If you get that, what I said just there, and we've been talking about it for a couple of days straight, then you've got the gist of this all day long. So the first thing I want to do is calculate, are these independent or dependent? And then we're going to figure them out. So 2 cups of coffee, 4 cups of tea on the counter. Dave drinks 2 of them. What is the probability that the 2 he drinks are coffee? Does that sound independent or dependent? Sounds very dependent unless he's back in the cup and putting it on the counter. And then he's just sicko if he re-drinks what he just did. So very, very, very dependent. And if it's dependent, I have 2 options. I can use combinations because it never specified order. So let's try about that. How many ways could he drink 2 cups of coffee? 2C2. Yes. Hold on a second. Hey. There with me. Okay. Check it out. All right. So I'm drinking 2 cups of coffee. There's 2 to choose from. So 2C2 right here. This is one way to do it. And by the way, guys, on my keys, sometimes I don't show both. It's not a preference. It's just I probably should go back and redo all of them. But to redo the keys, it's 20 minutes. To upload them, it's 5. To do that with 3 Casas is an hour and a half a day. So sometimes you'll see an old key up there that doesn't show both. Hello? Sure. Mm-hmm. Back desk. Anybody else? All right, so 2C2. Now, how many ways could he choose 2 cups from the total? 6 to choose from, 6C2. Do I have to count the number of ways this could happen? The order.
No.
It's in there. Combinations account for that. You don't even have to think about it. Now, what if I chose these and found the probability one at a time? All right. So I'm going to go coffee, then coffee. So what's the probability on your first choice that it's coffee? 2 out of 6. All right. So you pick one, you drink it. Oh, it's coffee. Great. I needed a boost. Now I reach for the second one. On the second choice, what's the probability that it's coffee? 1 out of 5. Now, do I have to count the number of ways on this that coffee could be had? Technically, yes. But when you do it, how many ways can you arrange CC? Once. But if you just went through the motions and said, well, there are 2 letters, 2 factorial, but 2 of them match 2 factorial, well, 2 factorial cancel. So if you happen to forget it on this one, you got lucky. You don't need it. So whether I put it or not, I don't need it. And if you do the math on both of these, they're equal. What about this? Bag, 5 oranges, 4 tangerines. I select one, replace it, select another. What is the probability that both are oranges? Now, this is replacement. So if it's replacement, what can I not do? That. I cannot do combinations and permutations because this is an independent event. Are y'all seeing that? So I'm forced to think this way. Okay, I'm getting an orange and an orange. All right. So first orange. What's the probability that I get an orange out of this situation? There's a 5 out of 9 probability that I get an orange. And an orange on the second situation. Another 5 out of 9 because I put it back, or 5 out of 9 squared. Probably be easy to do 5 out of 9 squared. And again, do I have to count the number of ways that I could have gone orange, orange? Technically, yes. But again, you can see there's 2 letters there, or like if you think about it, 2 factorial, but both of them are the same. That would have canceled. So if you had forgotten it, you would have been fine on that one. All right, what about this one? A green die and a red die are thrown. What's the probability that a 4 shows on the green die, a 5 shows on the red die? So let me show you this. A lot of people miss this because they think, oh, I could get a green on, I could get a 4 on one and a 5 on the other, or a 5 on one and a 4 on the other. But wait a minute. It specifically said that I'm going to have what? A green die that has a what? 4, and a red die that has a 5. So I can't go 4, 5, 5, 4. If I didn't specify colors, I could, but I did specify color. So really, what's the chance that that happens? 1/6. And what's the chance that that happens? 1/6. So 1/6 times 1/6. Very independent, right? That probability did not affect that probability. Now, if I didn't specify, oh my gosh. Unbelievable. I think the record's 4. Hello. Why not? Take them all. All right, thanks. It is you. Yeah. Did you know? Oh, okay. That you're just being fun. Who's next? Anybody else?
I'm supposed to be leaving.
We got 2 more minutes. All right. Okay, what about number 5? Let me squeeze this one, and that's pretty good. And guys, again, your job, go through and do the best you can on. But look at number 5 right here. In a bag, 4 red, 4 green, 7 blue. 3 are picked in order without replacement. So it is definitely a dependent situation. And on dependent situations, I can use combinations or permutations. But what did they finish up with? What's the probability of doing that in that order? So I can't use combinations, but I can use permutations. So I want 1 red. How do I count that? For P1, or actually you could just say 4, because there's only 4 reds. You're picking one of them, right? Whenever you're picking one, you could just say 4. And then a green for P1 and a blue 7P1. And then divide it by what? 15, key 3. But the other way, just saying, okay, I'm going red, green, blue. What's the probability of getting a red? 4 out of the 15. What's the probability of getting a green? 4 out of 14, because one less marble. And what's the probability of getting a blue? 7 out of 13. But do I have to do that thing right here? Why not? Because there's only one way to go in that order, so times 1 would not change. But if I didn't specify that, I would have to go 3 factorial over 1 factorial, 1 factorial, 1 factorial, which is just 3 factorial. Or I would go with C's here. But the in that order eliminated that and changed that to P's. See what you can do. For the record. What do you want? That's interesting. All right, tell me what.
I thought it would be the first time and then the second time.
You're like, they forgot me.
I still went through that. I still have it. I just have to walk
Hey. I'm missing out. You have a sunny day that has cloudy skies. When it's cloudy but sunny, you know, you get great sunsets. It's gonna be one of those. Nice breeze blowing. Look at that flag. Just bang.
Yeah,
Hey, did y'all notice that the flag was stuck on the top for a while?
I guess because you pointed it out.
It ripped,
It's still ripped, yeah.
but it's stuck on the top.
Oh.
There's 2 big chunks blowing off that eagle.
Alright.
What's up? Anything else outside?
I run sleep outside.
Nah. Need to be in here. You gotta.
Not really. I mean, didn't you say we have a bunch of extra days? Aren't we?
We do not have extra days.
No, don't we have like 3 days to go with probability? Like 3 days.
Yeah, but
didn't you
I
say
will
we already
say
need
this.
to know all the things we need to know?
That doesn't make any use. Like I always have. In fact, normally I have an extra day. Normally I do an extra review, and I had to cut 1 review out.
Aren't you like checking probability like a little bit?
I don't know. Depends how it plays out.
We could just cut probability.
I
a
think
little
I'm
bit
doing
and
a
go
better
outside.
job communicating it this year.
We could cut probability a little bit and go outside right now.
Yeah, but listen, I mean, seriously, like, what's the goal of school? It's to make yourself better, right? Why would you sell out? You got the whole summer coming up.
Because me and Ken had a bunch of other people in the class had the AP exam. So now we got
Today?
yeah.
Okay, so let's erase that. Those horrible memories of A push.
By going
And replace
outside.
them with probability. Mathematics. Can't beat that, right? Fill your brain back up with combinations and permutations. Erase the past, literally. Not to mention, I have a gift for y'all. You may not like it.
Oh. It's a behavior problem. I was done it yesterday. And then I stopped looking. Yeah, I'm gonna finish my. Yeah, but you can automatically.
No, it's both.
Perfect is kickball.
Actually, this would be a horrible day for kickball.
If you bust,
If you'd crush it, we always go that way. You kick it to be like,
it'd be funny.
Yeah.
We should
Yeah.
play kickball. We should play kickball one day. That's kind of like a family video.
I don't know. If we had 4, I'd think about it. We only have 3 at most.
And one of them might not even be there. Which means you really only have two with me. There's a chance of that. I've 10 spin shut.
Okay, we got 14th in that state.
Yeah.
16th. So, terrible.
How'd you do personally?
I lost twice against the second team.
Or you were your second seed on
No,
that?
like the team we played was.
Oh, I got you.
Like,
Hello.
Ow. Ow.
okay.
Phones. I got 5 phone calls for checkouts in the last 15 minutes. It's like it won't stop ringing.
Yeah, what?
It's served.
There's really no point in doing that.
Yes. Sorry? No, not today. Not today. I might take about, I'm gonna take them all up. I just might not take them up today. Yes, but it's not like, I don't know that I might be following it. Yeah, I guess I am.
Well, our grade.
I've just kind of been like, oh, I don't even know.
All right, guys, so I asked you to do probability part 1 as best you could, and then to bring in some questions. So does anybody have any questions about probability part 1? And by the way, if you weren't able to do the math team problems, don't sweat that very much. I mean, those aren't the kinds of questions I tend to put on these tests. They just aren't, because they're very, I don't know what the right expression is. They're very standalone-ish. Like there's a uniqueness about them. And if you know anything about my tests, if you've done the reviews, the tests tend to be very similar to that. And I like to do problems that are very kind of common, that show a thread throughout the work that we've done, not some little unique thing that takes 5 to 10 points off your test because of one obscure topic. So I want to expose you to those and show you maybe a uniquer way to think, or maybe what they were looking for. But it's probably not much of what you'd see on a test, unless it showed up a bunch of other ways. So anybody have a question about this? Yeah. 42. Something is wrong with this screen. All right. So on 42, this problem, for the record, gave a lot of people issues in the other class as well. It says if 3 6-sided dice are tossed, find the probability the sum is less than 16. Think about it. The sum has to be between what and what? 3 6-sided dice. 3, which would be cat eyes, right? 1 1 1. Well, a 3-eyed cat. Or what? 18. So when I say less than 16, we're talking about the vast majority of the numbers, right? There is no way I am going to be able to count. And by the way, how many different options are there when you roll 3 dice? 216, because there's 6 ways to do this, and 6 ways to do this, and 6 ways to do this. So 6 cubed. So I know there's 216 ways to do this thing. It's going to be really hard for me to count what works. So here's what I thought. Why don't I say, all right, 216 on the bottom. Why don't I count the ways that it doesn't work? So the ways that it does not work, and subtract them from the total. And that will tell me the ways that do work. Are you with me? So what doesn't work for me here? 18, 17, or 16. So let's think about it. How many ways can you get 18? once, and that would be me getting a 6 and then a 6 and then the 6. So there's one way for that to happen. How many ways can I get 17? Well, if 18 is 6 and a 6 and a 6, 17 would just mean one of them would have to be a 5. So, but I could get that 3 ways though, right? Because I could get 6 on the first, 6 on the second, or a 5 on the third, or 6 on the first, 5 on the second, 6 on the third, or 5, 6, 6. So that means there are 3 ways that could happen. Now, the next one's a little bit more tricky to count, so be careful. How many ways are there to get 16? Because what I'm looking for is less than that. So 16 would be what? Give me some options.
6, 6, 4.
So 6 and a 6 and a 4 would work for me, but also what? Well, just keeping with that. 6, 4, 6, 4, 6, 6. So there's 3 ways to do that and get 16, but what else? 5, 5, 6, 5, 6, 5, 6, 5, 5. So 3 more ways for a total of 6. So there's 9, 10 different ways for it not to work. Subtract that from the total, and I get 206 out of 216, which reduces to what the answer was. So kind of a tedious kind of problem. Not something that I would probably give on a test. I can't really imagine that. I mean, I can give anything on a bonus. I don't really care on a bonus. I'll throw whatever at you because it doesn't hurt you. But that was, that'd be a tough problem to get in a minute in the first interval. I mean, even if you thought about it, you still got to write them all out, think about it, crunch the numbers, simplify. 2 minutes, yeah. But anyway, what else? 41. So in 41, okay, they didn't ask about this. It says Team and A both play a series of games. Whoever wins the first 2 wins the series. If Team A has a 70% chance of winning any game, which would mean Team B is what? 30. What is the probability that Team A wins? All right, so if Team A wins, how did it happen? Now you got to think about this. To find out if Team A wins, you have to figure every possible way Team A could win. So how could Team A win the series? Again, whoever wins the first 2 games. So Team A could do what? How could he do it? Win 2. So Team A could win and win. That would do it. Or what could happen? He could win the first, lose the second, and then win. That would still give him a win, right? Or what? Or he could lose, and then win the last 2. But he can't lose, win, can he? Because as soon as he loses 2, the series is over. So those are the 3 situations that could work for him. So let's do it. What's the probability that A wins again? 70. So 0.7. 0.7. What's the probability that he wins, then loses, then wins? 0.7, 0.3, 0.7, right? Because if he's winning 0.7, he's losing 0.3. And then lastly, 0.3, 0.7, 0.7. You seeing this? Now, this was a ciphering question. I don't love the decimals. I don't. You can deal with them if you want. It might have been easier to think 7 tenths, 7 tenths, and then 737 over 10, 10, 10, or 377 over 10, 10, 10. I would probably argue it might be easier to think like this and just find a common denominator. So 49, 490. Right here, 49 times 3, what, 147? 49 times 3, another 147. All of that over 1,000. So at this point, it just becomes a battle to how quick you can simplify. So if you added that up, you'd have what, a 14, 10, 18, 784 over 1,000. I know I can divide a 2 into that. And then I can divide a 2 into that. No, 6. 250. And then a 2 into that. 98 over 125. So 98 over 125. And again, probably not something you'd see on a test, very likely something that would be a bonus. But anyway, it's just checking, do they know what OR means? Do they know individual fundamental counting principle? And do they know a complement? If a win is a 0.7, a loss is a 0.3. Lots of little things that you could have there. But not something to beat yourself up over if you didn't get last night, for sure. What else? Anything else you didn't know how to do and you want to look at? So 2 dice are thrown, their sum is 6. So this is a kind of an introduction to conditional probability. So what they're saying is, you know for certain that the sum is 6. So that changes it from, hey, 2 dice are thrown, what's the probability that you got a 3 and a 3? If that were the case, and I didn't say anything about the sum, I would say, well, 2 dice, there's only one way to get a 3 and a 3, right? A 3 on this and a 3 on that. But how many ways are there to roll a die? How many ways are there to roll 2 die? 36, 6 on 6. So if it didn't say their sum is 6, I would say there's one way to get both 3s, 36 ways to roll 2 die. I would say that. But this said, wait, you know their sum is 6. The sum of 6 can only happen a few ways. And what is that? A 1 and a 5, a 5 and a 1, a 4 and a 2, a 2 and a 4, or a 3 and a 3. There are only 5 ways for that to happen. So given that their sum is 6, okay, it has to be this. Everything else is off the table. What's the probability that they were both 3? Well, 1 out of those 5. So that's an example of conditional probability. Conditional probability at this level, not so bad. Conditional probability can get really dirty. Like they don't really put them on math team tournament tests anymore, but they used to. And I remember fighting my way through it. Nobody ever taught me that, and doing examples, and it is not pleasant. It is not. At this level, not so much. But they can be really, really ugly. What else? Anything else? If you're skipping this, I am going to be taking all these up. I may not take them up that very day because I want to be able to go over with them. But at the very minimum on test day, you're going to give me probability 1, probability 2, probability 3. And for the record, if you look at your assignment sheet, I have 2 probability reviews on there, but there are actually at least 3 either reviews or practice tests or whatever in your book. So if I were you and you do those first 2 and you check them and you're like, oh, I know this stuff. Well, maybe you take a vacation if you want on the third one because it's not assigned, right? And the titles look very close. Like one will say probability, one will say probability and counting, one will say counting or whatever. So the one that's not given, you don't have to do it. But if you were struggling, it might be a good idea to get a little extra practice. What else? Anybody else on any of this? 48. Okay, so I thought this was kind of tricky the first time I saw it. But this is what I came up with. It said the odds of pulling a blue marble from the jar are 5 to 3. So what would that mean about probability? What would that mean about the probability of getting a blue? If the odds are 5 to 3. 5/8, okay? So I will say that it's been a while since I've seen this problem, but this is what I imagine I thought. It says, if I add one more blue marble to the jar, this is probably my first mistake. I thought, okay, that would be 6 and then 9, right? 1 more blue, 1 more total marble. It said, then the odds are 7 to 4. And I looked at that and I'm like, wait a minute, the odds should be 6 to 3. And then it dawned on me that the fraction might have been simplified, right? I didn't say that there were exactly 5 blues and 3 others. It could have been 10 to 6, 15 to 9, right? So I thought, well, maybe I canceled something out. So I changed my thinking to this and said, all right, 5 to 8 represents the simplified probability. maybe there was some other multiple in there, like times 10 over 10, 20 over 22 over 2. Are you processing that? So, and that would have canceled. So I just put a variable to represent maybe what was canceled. And then I said, now what that means. So this is what I originally had, blue, and originally had total. So what the problem says now is, if I add one more marble to whatever that was, that would also add one more marble to whatever the total was, right? And then what does it say the new odds are? 7 to 4. So your new probability should be what? 7 to 11. So if I add one blue and one total, that should equal 7/11. And all I got to do is cross multiply and solve. So you see, when I cross multiply, it actually works out really nicely. I get 55x plus 11, and I get 56x plus 7, which when I subtract the 55 and the 7, I get this. And what did x stand for? That multiple I canceled. So the question was, find the number of blue marbles originally in the jar. Well, the number of blue marbles originally was 5x. So that must be 20. And again, probably not something you'd see on your test, but maybe a bonus. Does that make sense? I've seen that kind of question actually a decent amount, where they do stuff like that. Because again, everybody just assumes, oh, 5 to 3, there must have been 5 blue marbles. No, that could have been a simplified odds, could have been a simplified fraction and probability. We don't know that. And here's the great thing. Even if it wasn't simplified, when I solve, I'll get x equal 1. And that would just confirm that I had 5. So you can do that whether you think it's a simplified one or not. Just set it up like that and just go with it. What else? 47. Okay, I won't do this to you on a test. There may be a deck called a euchre deck. I've never even bothered to look it up. I know there are other kinds of decks of cards that that have cards missing. Like I didn't know that was called that, so it may or may just maybe made up for the problem. But bottom line, let's just pretend there's a deck of cards that has those 6 kinds of each suit, and you have the regular suits. So that would leave you a total of 24 cards, right? That many hearts, that many spades, that many diamonds, that many clubs. So the question is, does that make sense so far? So the question is, find the probability of getting a full house. Now, again, I'm not going to make this about having a knowledge of cards. So if I say full house, I'll probably write out what it is. But it's a good thing to know in this test that a full house means you have 3 of one kind and 2 of another. Not 3 of one suit. Like 3 hearts, 2 spades, that means nothing. But like 3 kings, 2 tens, that would be a full house. So the first thing I want to ask you about is this. Did I say which kind of card I was going to get 3 of a kind from? No. So you have to count the number of ways that could happen first. So how many ways could I get? How many different kinds could I have when I pick my 3 of a kind? 6. Now you can also say that as, you don't have to here, but you could also say 6C1. 6C1 is a safer way to do that, and you'll see that when we get to Monday's work. Because sometimes, well, I'll just say it. But there are 6 ways to do that. And it just so happens that 6C1 is 6. Now, that's saying basically, okay, I could get a 9, a 10, a jack, a king, or queen, or an ace. Now, once I get that card, or once I know which kind it is, how many ways can I pick 3 from those kinds? From that kind. 4C3, because there's 4 kings, I'll get 3 of them. Or 4 queens, I'll get 3 of them. Or 4 jacks, I'll get 3 of them. So 4C3. So this right here is me picking the 3 of a kind. Now, just to make that clear, if this problem had said 3 kings and 2 queens or whatever, 3 kings, I would just have 4C3. 2 queens, I would just have 4C2. But because I didn't specify which kinds they were, and there's a lot of different there's a lot of different kinds it could be, I've got to count How many different ways could I get 3 of a kind? 6. That way, that way, that way, that way, that way, or that way. All right, so let's move on to the 2 of a kind. Once I've picked one of those kinds, now one of the kinds is off the table, right? Right? So how many ways can I now get 2 of a kind? Well, how many different kinds are there to choose from? 5 remaining, and you're picking how many? 1. So 5C1. Now, that just decides which kind is going to have 2 of a kind. But from that kind, say 10s, how many ways can you pick 2 10s from those 4? 4C2. Are y'all seeing that? So 4C2. And that chooses the number of ways to get 2 of a kind. And if you wrote 6 right there for the 6C1, 5 for the 5C1, that would be okay. But I'm going to caution you, it's going to be a little trickier than that when we get to the cards. I think we're going to have time to get it in. If we don't, I'd probably cut them from the test, but we'll talk about this a little bit later. And it's actually something that I taught incorrectly for easily 15 years. Because I'm always pushing the envelope on how I teach and trying to learn more and trying to shove it down your throats. And I didn't even know I taught it wrongly until I looked up on, have you ever played around with Wolfram Alpha? Wolfram Alpha is a really cool program and it can solve almost anything. And it's actually what Siri uses when you say, hey, what's the integral of x squared? It'll or whatever, it'll pull up and it'll say Wolfram or courtesy of Wolfram and it'll have it solved. But it's this program where you can literally type in, what's the probability of getting a full house? And it thinks for a second and then bam. And if you have the updated version, it actually walks you through what they did. And I remember when I did it the first time, my answer for this question was correct. But there were a couple versions where I'm like, what is that extra fact? What is that extra combination? Because I normally write 6 and 5, which is true here. And I saw this extra weird combination. I'm like, oh my gosh, I didn't even think about that. Anyway, point is, we'll talk about that on Monday. And then what goes in the bottom? 24C5, because there's 24 total, and you're picking 5 of them. And at this point, we don't care what happens in the denominator. Any 5 cards would work. And now they made you simplify this in a ciphering question, which is a lot of tedious multiplying, especially this one. That's pretty easy. 6, 4, 5, 6. But that 24, 23, 22, 21, 20 on the bottom with another 5 factorial on the top. I don't know how anybody got that canceled and simplified under a minute. That's a lot of, just to write it out takes you a little bit of time and thinking. And then to simplify it, you'd have to really be moving to get that in the first interval. But anyway, you won't have to simplify. What else? Anybody else? That is something I would put on test, by the way, for what it's worth. I just won't make you simplify. And by the time we do it, we'll have done a whole day of card problems. That won't be a big deal. Now that the ugly version of what I give you, you'll see that. And you won't even see it coming. You're like, why can't I? That's a little trickier. But it's not like I fill the whole test up with those. Maybe 1 or 2 problems. Anybody else? Anything you skipped, did not do, want to see? All right. Okay, so jumping on to the next page, I really think I've done a much better job this year than in years past about already talking about independent and dependent. So right here, this is going to be my introduction to that, to really emphasize it. But we already know that independent means what? In your own words. Anybody? Don't be shy. Take a risk. Be a hero.
Like the number of events, they're all separate.
So there's no way that one outcome will impact another. Absolutely. Examples of that would be what? I can think of 3 quick ones. Do what? Flipping a coin, right? No matter how many heads you get, that unless it's a fake coin or a double-headed or heavy weighted or something like that, we know that it's still 50-50 heads tails, right? Rolling a die, unless it's a weighted die or a die that has a 6 on every side or something like that, we know that there's a 1 in 6 chance all the time, right? What's another situation that could turn any dependent one into an independent? With replacement. So if you see situations like that, then you know that it is a independent situation. Now, to make matters a little ugly, especially for those of you that are maybe baseball players, let me ask you a question. You have a batting average, right? If you're a baseball player. And every time you get up and either get out or you have an official at bat, what happens to your average? It changes, right? Now, you probably don't run back to the dugout and figure that out, but it changes every at bat. Like, so for instance, if you don't know what a batting average is, if you're batting, say, 300, 300 means you have a 0.300 probability or a 3 in 10 chance or a 300 out of 1,000 chance of getting a hit based on your previous at-bats. And all they do is calculate your official at-bats and how many hits you have, and they divide it and you get that decimal. Except they don't say you have a 0.357 or whatever. They say you have a 357 average just to be short for that. But every time I get up, my batting average changed. You're probably not paying attention to that. I mean, when I was a kid, I would go home, and if I went 3 for 4 or 1 for 4 or whatever, I would go home and recalculate my batting average to see what I had. Okay, every time. But I didn't do it after every at bat. But every at bat, my batting average is changing. So that is definitely what kind of a situation? Dependent, right? Here's the problem with this. What if I say, and I literally have this question there, Tarzan is a 300 lifetime hitter, has a 0.300 batting average. Tarzan, what's the probability that he gets 5 hits in his next 7 at bats? Well, what's the problem with that? Let's just say Tarzan got a hit on his first at bat. How do I change it? If I'm a 300 lifetime hitter, was I 3 for 10 and now I'm 4 for 11? Or was I 30 for 100 and now I'm 31 for 101? Or was I 300 out of 1,000 and I'm 301 over 1,001? Do I know that? I don't. All I know is this decimal. So in that situation, if I say that Tarzan is a 300 hitter, I got to kind of assume that he has a 0.3 chance of getting a hit and a 0.7 chance of not getting a hit. And since I don't have enough information to change it, I kind of got to think about that as an independent event, even though it's really not. Are y'all with me on this? Like today, right now, when I woke up, when I went to bed last night, I looked up and there was a 92% chance of rain today. I have not seen a drop of rain today. I woke up, I walked outside at about 7. It had already rained. It's been cloudy or sunny or whatever all day because it rained earlier, right? And I guess it ran out of rain, the clouds or something, however that works. I mean, I do understand, it rains and then evaporation and all that kind of stuff. But the point is, the rest of the day was affected by that, right? Kind of. It dumped all the rain. Clouds weren't as heavy, weren't as accumulated with precipitation or whatever, and we got less rain. Well, technically, that's a dependent event, but I don't know how to calculate that. It's kind of like if I told you, hey, it's summertime, it's April, or what? It's not April, but let's say it's May. There's going to be a 20% chance of rain on average every day this month. Well, that doesn't mean, but you just kind of go, if it rained in the morning, it might not be raining the rest of the day. If it rains all day today, it might not be raining the next day because the front blew in. We don't know that stuff. So sometimes if I say that, I'm like, well, on any given day in May, I got to assume a 0.2 or a 0.2 probability. I'm just going to stick with that. So sometimes actually dependent situations have to be thought about as independent. And you'll see those on the reviews. You'll see them again on the test, so they won't be a surprise. So it shouldn't be like, wait a minute. Because if you don't have enough information to recalibrate and adjust and make it dependent, you got to treat it as independent. Are y'all with me on that? Here's a better example. Playing cards. Have you ever played blackjack? So blackjack, 10s, jacks, queens, and kings count as 10, right? So if you're ever playing blackjack and the dealer puts down 13, you're kind of happy, right? You might not even have a good hand. You might be showing 14. And you're like, he's got 13. There's a really good chance. I don't know exactly what the numbers, I'd have to figure it out. But there's a really good chance he's going over. So a lot of times, even though I have a crappy number, I'll go, I'm good. The dealer takes a hit. A lot of times he gets a 10, he busts, and I win, even though I didn't have a great hand. There are sometimes the dealer will show 16. I'll only have 15. There's a great chance he's going to go over. So I'll go, I'm good. Even though I'm currently losing, I won't take a card. Dealer hits, he goes over. Now, technically, every card that has been played out of that deck is affecting it, isn't it? The cards, the hand you just had might have had a bunch of tens, queens, and jacks. But how many of us are card counters? Not many. But if there are a lot of tens, jacks, and queens that have been played, and you've been keeping that in your head, right? You've been counting those in your head. You're like, man, there are not as many tens, jacks, and kings out there. That's affecting the situation. But if you're not counting cards and you're just enjoying yourself in Vegas or whatever, you're like, there's a good chance he's going to go over. I'm going to bet that he's over. Okay, or not take a card. Those are examples of real life dependent situations that you're kind of treating independent because you're not gathering all the information or you're unable to. For whatever that's worth, let's move on. Okay, so remember that. And what do we say about dependent situations? With dependent situations, because of the nature of, hey, there were 10 blue, and now there are 9, and now there are 8, now there are 7, and now there are 6. That's very factorial-like. We are allowed to use what for dependence? Well, yes, but because of the factorial, we're allowed to use combinations and permutations to do those. But on independent situations where that thing's not changing, probability of the head, 1/2, 1/2, 1/2, 1/2. Or on replacement, I get a king, I put it back. So there's 4 chances. I put it back, there's still 4. I put it back, there's still 4. Situations like that, the factorial is not showing up. I can't use combinations or permutations. I have to look at each individual choice one at a time. So today, this part 2 thing looks at a lot of that. So I want to walk you through some random ones. What about, let's just jump to number 2, and you can fill in with what we don't do. So there's 5 oranges, 4 tangerines. I take one, replace it, take another. That's replacement. That makes this what? Independent. I cannot use combinations or permutations. So I don't even try to do something like 5C1, 4. I'm not doing it. So I just go, all right. So basically, what is the probability that I go orange, orange, and don't take a tangerine? So I'm going to write that as a probability of getting an O. I'll write OR. So I'm getting an orange on my first pick, and then I'm getting an orange on my second pick. So I can't use those. So I take one probability at a time. So first choice, reach in the bag. What's the probability that I get an orange? 5 and 9, or 5 out of 9. Second choice, I replaced it. What's the probability that I get an orange? 5 out of 9, right? Or you could just say 5 out of 9 squared. Now, how many ways can I get an orange and then an orange? I mean, how many ways can I arrange that order? Well, isn't orange, orange the same as orange, orange? Like if I was making new words out of O and O, isn't OO the same as OO? So it's really just one way. Now, if you want to be like consistent and say the whole Mississippi thing and say, well, there's 2 O's. So there's 2 factorial ways to go OO, but they're matching letters, 2 factorial. And that cancels and gives you 1. If you didn't put it at all, totally fine. All right, what about 3? A green die and a red die are thrown. What's the probability that I get a 4 on the green and a 5 on the red? Well, be careful about that. I see people go, oh, well, you could get a 4 on one and a 5. And a 5 on the red. They say, oh, you can get a 4 on one and 5 on the other, or a 5 on one and a 4 on the other. No, because I specified color. So they were very clear about saying a 5 on the red and a 4 on the green, right? So how many ways can I do that? Once. I can do that one way. So if I do that one way, well, how many total ways can I roll these 2 die? 36. So 1 out of 36. Now, be careful about that, because what if I don't say anything about color? What if I say 2 die are thrown? What's the probability of getting 4 on one and 5 on the other? Well, then what are my options? I could get a 4 on one and a 5 on the other, or I could get a 5 on this one and a 4 on that one. That would mean what? There's 2 out of the 36 or 118. So the color kind of makes it almost like in that order, right? There's one way to do that, one way to do that, 136. But I didn't I did say color, so we got to go 1 out of 36. What about number 5? Number 5 says, in a bag are 4 red, 4 green, 7 blue. 3 are picked without replacement, which if I didn't say that, we would assume without replacement. What's the probability of getting a red, green, and a blue in that order? Now, is this dependent or independent? Dependent, right? Because I'm not putting them back. But because I specified in that order, I can't use a combination, but I could still do a permutation. So with a permutation, I would say, all right, I need 1 red. So how many ways can I get 1 red marble? 4. But if you want to build good habits, 4P1. Because if I was picking 2 reds, I would want to go 4C2 because that's just not 2 ways. That's 6 ways. Right? How many ways can I get 1 green? 4P1 again. And how many ways can I get 1 blue? 7P1. And how many ways can I get 3 marbles from that? 15P3. But because it is dependent, I have 2 options. I could also say, all right, I want to go red, green, and blue. Red, green, blue. What is the probability of going red on my first pick? 4 out of 15. Green on my second pick. 4 out of only 14 left. And blue on my third. 7 out of only 13. And do I do that stuff out front where I count the number of ways to arrange those 3 letters? Not this time. That's why I don't use C. That stuff out front would have come from that extra factorial that C gave. I don't do that for in that order because that's the only order I get. RGB. There's one way to go RGB. So don't do that 3 factorial out front because there are not 6 ways to go RGB. There's just 1. Red, green, blue. To arrange that order. What about looking for something different? How about number 9? 5 red, 4 white, 7 blue marbles. 3 are picked in succession. What's the probability that there? I tell you what. It's got to be something better than this. We'll go with this one. Same one I was reading. Number 9 and 10. But I tell you what. Do that. We'll just do it in that order. What are the ways I can do it? So I want red, white, blue in that order. No replacement. So no replacement is dependent. Dependent, I can use combinations and permutations, but because it said in that order, I can only use permutations. So let's go with the permutation, then we'll write out the fraction. So I want to go red. I want 1 red. So how many ways? 5 or 5P1. Then I want blue. Sorry, then I want white. How many ways? 4 or 4P1. And then I want blue, which is only picking 1. It's 7 or 7P1. I like using the P's like that rather than just saying 7 because as soon as it's more than 1, it's not going to be just 2 or 7 or whatever. It's going to be that factorial that you have. And then how many total ways? 16P3. And then the other option would be, all right, I'm going red, white, blue. So red, white, blue. What's the probability of getting a red on my first pick? 5 and 16, then a white. 4 out of the remaining 15, then a blue. 7 out of the remaining 14. And do I mess with anything in the front because it said in that order? I do not. Now, what happens if I get rid of this right here? If I got rid of in that order, what would you do? Don't change your math, but just answer the question. What would you do there? I put 3 factorial over 1 factorial, 1 factorial, 1 factorial, which is not really necessary. So 3 factorial. What would you change here? C's. Change the combination. And they equal each other. So you have no worries. Now, what if replacement occurs each time? Then what can I not do? It becomes what? If I put them back, then I can't do factorials, which means I can't do that. So this becomes an independent situation once I start replacing stuff because nothing's changing or putting it back. So I would not be able to do permutations at all. So I would have to think, all right, my only option is red, white, blue. So what changes about the fractions though? The denominators don't change. And if I had picked more than one kind of a marble, it wouldn't reduce in the numerator either. But here I have a 5 and 16, but then I put the red back. Then I have a 4 still out of 16. I put the white back, and then I have a 7 still out of 16 because I put the blue back. And because it still does say in that order, I do not put anything out front there. So 2 ways to do this one, and just this one way to do this one. And I don't need you to do them both. Pick one. And by the way, every year I have somebody say, well, I've been looking at these problems and it seems like you can always do this. So why don't I just abandon the combination permutation thinking, because then I can simplify it, which is great, except for this. A bag contains 500 red, 400 white, and 700 blue. If 300 marbles or whatever are chosen, what is the probability that 75 are red, 100 are white, and 125 are blue? Well, then your fraction becomes kind of tedious, doesn't it? And if you're on, and especially if it didn't say replacement, what am I going to have to do here writing fractions? I'm going to have 300 fractions. You do not want that, okay, at all. So knowing permutations really would make your life easy, wouldn't it? Now, right here, at least you'd have 75 reds, 100 whites, right? 125 blues, because this never changes. It's the same fraction over and over. But it would be really ugly on a dependent situation. So that's why it's nice to be flexible and have a little bit of both going on. I'm going to leave you that one. You'll probably ask me about it, but I'll leave it to you. How about, here's that batting average with the Tarzan thing. So it said, like, and again, most people aren't overly thinking about this, but the question was, what's the probability that he gets 3 hits in his next 5 times up? And if his batting average is 0.300 or a 300 batting average, that means he has 3 hits in every 10 at bats on average. Well, that would mean he gets out 7 out of every 10. So his out rate would be 0.7. So if I said, what's the probability that he gets 3 hits? That's hit, 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 out, out. Are you with me? Now, technically, the first time he got a hit, 300. First time he got a hit, his average went up. But I don't know how to recalibrate that, do I? Because I don't know his total number of hits and his total number of at-bats. So I just have to assume that he's just kind of a lifetime 300 hitter, even if he got in a slump, right? Because, I mean, he's Tarzan. Maybe he's hit like hundreds and thousands of times. I don't know. So I just kind of have to assume independence there, even though technically in real life it would be a dependent situation. So hit, 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 out, out. Now, what would I do wrong right here? What is wrong about me going hit, hit, hit right there? This is hit, 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 out, out. What's wrong about me leaving it like this or even simplifying it like this? What did I forget? It could happen in different orders, couldn't it? I mean, I don't have to go 3 hits and then 2 outs. I could have had 2 outs and 3 hits, or I could have gone hit, out, hit, out, hit. There's a lot of different ways. How many ways would that have happened? And that's where that comes into play, right? And you don't want to count them. You don't want to do this. You could. It's tedious, but it's going to be really hard when it's 10 at-bats or 100 at-bats to figure that kind of stuff out. So we just say, wait, 5 total at-bats, right? 5 letters, H-H-H-O-O, 3 factorial, 2 factorial in the denominator. And then we're not going to simplify any of this stuff anyway. So we're just going to leave it as that. Or even better, that part with 3/10 cubed, 7/10 squared. But again, we're not simplifying this stuff. Oh, and one thing, I get this 100 times. I mean, I've gotten this hundreds of times. Tarzan's batting average is 300. Happens all the time. what's the probability that he gets 3 hits in the next 10 at bats? And I have people go, 100%, because he's a 300 hitter. Is that true? No. I mean, Tarzan could get up and strike out 10 times in a row. He could get up and go 9 for 10. Now, what is the most likely scenario? That he goes 3 for 10. But if you do the math on it, it's probably not even over 30%. There's probably like a 25% chance that he goes 3 for 10. It's not likely. It's just more likely than anything else, because he could go 2 for 10. He could go 4 for 10. He could go 1 for 10. He could go 5 for 10. He could go 0 for 10, 6 for 10, 7 for 10, 8. There's a lot of situations. The most likely one is 3 for 10. And you'll see it. If you were to calculate anything else, 4 for 10, 1 for 10, or whatever it is, anything else is going to be lower. Right? But watch, for 3 for 10, 3 hits means what? HHH, hits cubed, and then out 7 times, outs to the 7th. So what's the probability that he gets a hit? 0.300 or 0.3. You're welcome to write 0.3. That's totally fine. And then the probability that he gets an out, 0.7 or 0.7. And make sure you do cubed and to the 7th, because it happened that many times, or write it out, each one. But how many ways can I arrange a 10 letter that has 3 H's and 7 O's? And if you do the math on that, I bet I'm going to guess like 24 or 27. I'll use this calculator much more. So the math on this is math probability. So 10 factorial over 3 factorial, 7 factorial times 0.3 to the 3rd times 0.7 to the 7th. 26.6%. So there's only a 26. There's a 1 in 4 chance, essentially, that he actually hits his average. But there's a greater chance that he hits his average than he hits any other average. It's most likely that he does this, but it's certainly not 100%. And every year I have somebody go 100%. Most likely does not mean guaranteed. Right? Just do the math and trust it. And you're not going to simplify anyway. A little time. How about this? Standard deck of cards. What is the probability of drawing 13 diamonds? All right. Probability of drawing 13 diamonds without replacement. So without replacement means what? Dependent. Now it's 13 cards. That's a lot. I'd rather use a combination in that case. So how many ways can I draw 13 diamonds? 13C13. So 1. The only way to draw 13 is to get them all. It's one way, and the order doesn't matter. But you're welcome to write 13 or write 1. I probably on my key have 13C13. How many ways are there to draw 13 cards, period? 52C13. All right. What changes from 23 to 24? What's the probability of drawing 13 cards of one suit? The only difference is what? I didn't specify diamonds. So how many different ways could it happen? 4. Now, isn't that kind of the same thing as saying there's 4 suits to choose from first, right? First, I got to count the number of ways to do the suits. And I got to pick one of them. Well, that just happens to be 4. So if you wrote 4 times this, totally fine on this problem. But if you write 4C1, you're going to be better off when this math starts getting trickier. And then once you decide about the suits, within that suit, C13 ways to do it. What about 26? What's the probability of drawing 13 face cards without replacement? So how many face cards are there? Are there? What are the face cards? Jacks, of which there's 4. Queens, kings. Do aces have a face on them? So just 12 face cards. So what's the probability of getting 13 face cards without replacement? 0. Don't write impossible. Write impossible means the probability is 0. So definitely 0 there. What's the probability of drawing 13 red cards without replacement? How many red cards are there? 26. So 26 C13. Right? There's no guarantee they're all of one suit. But don't do this. Don't go 13C13 plus 13C13 because that's only counting what? All hearts, all diamonds. And it could totally be a mix of those. So this is saying 13 from the total, 52C13. And then that's just a zero that can't happen. All right, guys. Hey, do the best you can on these. Enjoy your weekend. Anybody walk in late and not get an exam review sheet? Did I give y'all exam review sheets?
No.
How much time do I have? All right, hey, I'm going to just give them to you. I will talk later about these. Guys, if you want to do well on this exam, every exam problem is hidden in here like a Where's Waldo amidst a whole bunch of other questions. Okay? If you want to do well on your exam, just know how to do everything. I am not taking this up for points. If what I just said makes you smile because you're like, sweet, he's not taking it up, I don't have to do it. Get prepared to get crushed. All right? Because there's a lot of hard ones, some easy ones, but this is over the entire year. And before you get mad about the entire year, know this. By me doing the entire year, it means I can't focus as deeply on any one topic. So it actually waters down the hardness of it. It's more, but probably a little less hard. All right? All right. You have a good one. So weird. Yeah.
Is there a way that I can see what my grade would be without with a test dropped? Sorry.
Yes. It's probably not worth looking at now because we still have more tests, but I will definitely do that with you once we get all the tests in. Probably be better to do that. All right. Yeah, man.
Because I think I have I think if I got that test dropped, it'd be like an 80